Good afternoon and welcome back again. We are in the new chapter, chapter 9. I know we have a gap between chapters, okay, because they are related to each other. That's why we play with the chapters. Later I'm going to upload this chapter for you, of course. So we have what you can see from here. We have a relation. Relation means that we have two sets, or one set, we make a relation with the elements between them. So the idea is what? A relation between each elements, how to do it. Maybe we have a one set and we have many relation on it. Or maybe you have a many relation, or sorry, many sets, one relation on them. So depending on the situation, I'm going to give you such clues. So today we are going to try, I'm going to cover 9.1 with you. As you can see, relation is a binary operation. Means that we have a cross between two sets. So we have an ordered pair. At least we have ordered pair. You can see from here, A and B, cross it. Maybe we have a cross relation between A and A, you remember that. So you can see from here, A and B, and here's a relation I defined on it. Why? Because relation is not alone a cross, it's a subset also. What do you mean by that? For example, if I have A equal to 1 and 2, B equal to A and B, then if I say this is the relation I'm asking, is that relation 1 and A, 2 and B, is that the relation? I'm going to ask myself, is that a subset of A cross B or not? So I'm going to cross A and B in my mind quickly, and I'll see is equal to 1 and A, 1 and B, 2A, 2B. So after, see this one's a subset or not? Yes, it's a subset. So it's a relation on A and B. Understood, dears? Clear? Good. So that's how we define the relation. It's a subset of A cross B. Maybe A cross B also is also a subset. So maybe the whole set, whole cross also is what? Is a relation. Okay, that's a general definition. Okay. You can see from here, we have a table, we have a 0, 1, 1. Depending on this relation, you can cross. I have a 0A, 0B. So 0A, 0B. I have a 1A, I have a 2B, so that's why we cross it. And you can see the diagram of it. We have a 0 relation with all of them, 1 with A, 2 with B. Also, we can diagram the relation. Town function is a relation. I'm not going to mention here because we mention function a lot. So, what do you mean by a set? A relation on a set. On a set means that I have one set, not sets. We have a one set. So when I say relation on a set, I mean A cross A. I mean A cross A. Look at this example. Here's the example A, the set of A, and here's the relation. Look, he say what? A divides B. So A equal to 1, 2, 3, 4. And I gave you the relation by defining. I say R is a relation is equal to AB such that A and B belongs to A. And where's the condition? A divides B. Means that if A can divide B without remainder, without fractions. I want an integer. So I can see I can build a relation as like that. So during the exam, you need to construct relation. How? I say 1 can divide 2, right? 2 by 1 to divide
1 by 1.
Right? Is equal to 2. So 1 by 1 first. Second, 1 by 2. 1 by 3. 1 by 4. How about 2? 2 by 2, right? 2 by 2. 2 by 4. How about 3?
3 by 4.
How about 4? Done. So when I say A divides B, means that can be divided without remainder, without fraction. So this is the relation. We make a relation on a set, on just set A. Understood? We didn't do A cross A. We just find the relation between. Do you have any question? And I can see this is the relation because it's a subset of the A cross A. Do you have any question, dears? Good. Now, we can also, down here's a relation you can see from here. And here's a diagram, you can do it. I think it's easy for you. We are going to use this example maybe 3 or 4 times. So kindly capture it. We need this example many times. So, what was the relation? The relation is what? If you have integer numbers. So my set is what? It's those elements that the first and the second location is like what? Check. A less than or equal to B. For example, in integer I have what? I'm going to start with a negative. So -2 and -2 here, right? Am I right? Why? Because -2 is equal at least. And -2 is less than what? -1. And -2 is less than what? 0. Am I right? And go on. How about 0? 0 is equal to 0. And I know 0 is less than 1. 0 is less than 2. And go on. How about 1? 1 and 1, because 1 is equal to 1. 1 is less than 2. 1 is less than 3. And go on. Can you imagine this set? This relation? What did I say? I say first location is less than or equal to the second location. Understood? And where is the set? It's integer. Integers contain what? Negative, 0, positive. Right? Did you understand? So depending on this situation, I'm going to make a decision. How about R2? Can you imagine? First location is greater. Let me start with the -1. So -1, look, we say A greater than B. It's the relation 2. So I say -3 -2 greater than -1. Am I right? 0 is greater than -1. Understood? 1. How about if I take a 0? 0 greater than 1?
No.
None, right? Yes, we have. Greater than -1, -2. We have many. How about 1? I say 1 greater than 0. 1 greater than -1 and go on. And you can see we have this one, so I'm going to cancel it because during the set notification, we don't have duplicate. Understood, dears? Good. And how about the third relation? We have equal or -1. Can you imagine? Listen, just imagine. You don't need to study here, actually. Just imagine. Yalla. Give me the element of the set like that. They. Yalla, dears, give me the set. Sorry? Let me start with any number that you like. -2, -2. He's right. What else? -2 with what? With 2. Or opposite of -2. Opposite of -2 is what? Is 2. Am I right? What else? Give me another number. -1 and -1. Am I right? -1 and 1. How about 0? How about 1? 1 and 1, 1 and minus 1. How about 2? They 2 and 2, 2 and minus 1. Minus 2 and 2, 2 and minus 2. Understood? Later I'm going to use those sets. I'm going to use each one. See, this one is symmetry, this one is a reflexive, this one is a transitive. So I'm going to apply the definition on it. So kindly at home, try to construct the relation R1, R2, R3, then you can answer the others. You got it? Good. How about R4? R4? Yalla. Element of R4 is like what? Tamam? Good. R4, R5. Yes. How about from minus? Yes? Minus 3. Yeah? Minus 3, all right. Minus 2. Minus 1. 0. Am I right? If A is 0, I'll get 1. 1, 2, 2. Just find it. Otherwise, you cannot answer the other things. How about that one? R6. Yalla. 0, 0, right? I can put all minus, right? All minus. Minus 1, minus 1, minus 1, minus 2, minus 2, minus 1. Am I right, Kaka? Do you have any question? Ask me, please. Yes. Which one? R5. Okay. A should be equal to B plus 1. If you put any number here, B, okay, here should be what? B plus 1. And here should be 1. Why? Because I know this is A, this is B. If A is 2 equal to 1 plus 1, yes. If I put 3 here, here should be 2. Why? Because I know 3 is equal to 2 plus 1. Here's the condition. First location A is equal to B plus 1. So if, for example, your B, if it's 5, I say is equal to what? 6. You got it? Tamam? B, put any number here, is your B. Here should be what? Plus 1. تمام؟ حتما. لوكيشني كم دائما دانيك جورتر لا لوكيشني دوم. تمام؟ سيري الرقم أنا كم minus 3 plus 1 is minus. يعني وش؟ How about R6? We say all of them 0 0. Am I right? 0 1, 0 2, 0 3, 3 and 0. Am I right? 2 and 0, 2, 1 and 0. You can see we can play with it. So can you imagine? You should imagine the elements actually. Otherwise, you cannot answer the others. You got it, dears? Kindly, I know you are tired, but you need to be here. Because this example, we are going to use them 3 times, each one. Example number 5 and number 7, I think. Okay. Now we have a definition. During the exam, I will give you the example like R1, R2, any of them, maybe 2 R, 3 Rs, I don't know, 3 relations. I say which one of them are reflexive? Symmetric, transitive. So what's a reflexive? Reflexive is what? Look, for all element, for all, you know what it means for all? Strong condition, all of them without exception, sorry. So for all A belong to the set, A and A should be inside the relation. If my A is, so reflex, if my A is equal to 1 and 2, my relation should have at least, then I can say R is reflex. Tamam? Let me check. Let you go to the example. So here's your set, and I'm going to use that one again 3 more times. We need example 5 and 7 a lot of to understand. So here's my set. So tell me, R1 is reflex or not? Yalla, quick. I'm studying now. You don't need to study. Even for the exam. Just understanding. Yalla, R1 is reflex or not? 1, 1, 2, 2, 3, 3, 4, 4. Do you have all? No. Where's 3? We don't have it. So it's not. You got it, Kaka? How about second? How about third? Yes. Why? 1, 2, 3, all of them. You're right. And 4, 5, I'm gonna leave it for you. I don't know. You don't have what? Where? We don't have a 3, 3, 4. No, my question is what? Reflexive. What's a reflexive? If you have an A, you should have an AA. I have a 1, I should have a 1, 1. 2, 2, 2, 3, 3, 4, 4. How about number 6? Of course. Do you have any question about the first example? First definition? Dears? Hello? Good. How about example number 5? They are? Can you imagine they are reflexive or not? I'm going to example 5. R1 is reflexive? Because we have an equality, yes. Any number in the Z, you are going to take it 0 times an infinite relation, you can see. The first example was finite, 1, 2, 3, 4. But for that one, it's infinite. But you can imagine, we have a 0, 0. We have a 1, 1, 2, 2, 3, 3. So depending on the relation for R1, yes. How about R2? No. Do we have a 0, 0? No. On one example, it's enough to make it a counter, right? If I gave you, I say it's not reflexive because of what? Because in R2, example 5, R2, I say because is not reflexive. Why? Because 0 belongs to the Z, but 0, 0 does not belong to R2. Am I right? One example. Maybe your friends say 1 and 1. It's okay. Now, R2 is not. R3. No. Yes. Yes or no? Look at the elements. How is it? Yes, we have equality. 1 and 1, 0 and 0, 2 and 2, 3 and 3, 4 and 4. Yes. Minus 1, minus 1, minus 2, minus 2. Yes. You got it? Kaka? It's also yes. How about R4? 100%. Right, 100. There's no way. R5?
No.
No way. R6? A little bit tricky. I don't see is lower or greater. I say yes or no.
No. In one, A equals minus.
In what situation?
No, my question generally. is reflexive or no? No. Why? Give me one example. 0, 0 and 3. What do you mean by 0?
It multiplication, right?
Yeah. Yeah. So you can bring 0 or 3. Which one?
Minus B.
Why minus B in Hardullah? It's easy, Kaka. My question is what? Yes, they are reflexive or not? Yes, Kaka. Yes. Tankoti is thought. Generally, you should show. They. No, give me one example. 3, 3. 4, 4. 2, 2. Also, yes? 2, 2. How about 1 and 1? 1 and 1. No, you cannot say 1 and 1. How about 0, 0? No. Because 0, 0 and all minus satisfy the condition and they are exist. Till minus 100, minus 100, we have it. Minus 2, minus, we have it. Minus 1, we have it. 0, 0, also we have it. 1 and 1, also we have it. But add 2, starting to not have it. 2, 2 is equal to 4. 2, 2 is not in this relation. It's not in the R6. So you can say R6 is not. R6 is not. And in example 5, we mean. Why? 2 belongs to integer, but 2 and 2 does not belong to here. You can say 3, 5, whatever, 4. Understood? Don't say we have till there. It's not my problem. I say yes or no. You say yes, you can't show me everything. You say no, give a counter example. Understood? So do not do any change. Do not change it minus B, nothing. Just say yes, no. Yes because that one, no because that one. And of course, the no, you should give me the counter example. This is about the reflexive. How about here? Examples. We say that. We solved that. So, this is about the example, and that one will be your homework. Divides. Let me do it for you. So, okay, Qaina. Divides relation on what? On positive integer. Divide this. You know what's a divides. A divides B. So that relation, or A divides B. That relation, do you remember? Is the reflexive or not, and why? Yalla. Can you put your mobile away? Not you, Kaka, not you. Not you, behind you. Okay. Yalla day. Come on, what are you doing? Sahart? Imagine the set. Imagine the set. We have A, look. Example 9, right? To the example 9? Okay. We have AB. Here's the relation. Set of all AB. A divides B. A and B belongs to Z positive. So tell me, do we have a reflexive or not? Yes. Yes, we have. How about any other? No. Give me counter example. No, divides. The set is like that, Kaka. One divides all of them, 1 by 1, 1 by 2, 1 by 3, 1 to all. 2 by 4, sorry, 2 by 2, 2 by 4, 2 by 6, all. 3 by 3, 3 by 9, 3 by 6, 3 by 9, I like that, yes. It's right, yeah. So we have, each number can divide itself, right? Each number divides. So it means if you give me the 100, I see 100 divides 100. So it's in this relation, am I right? Yes?
Divisible.
Yes, divide a bit. Divide يعني A جێکەوتەی یەکەم دیڤایدی B ئەکا بەبێمانەوە. سەد دابەشی سەدەکە yes. یەک 2 2 3 3 like that. Understood? Okay, so yes is reflexive. Now I'm going to change the question. Example 9 star. I say R is the relation A and B such that A and B belongs to Z. A divides B. Yalla. No, give me an example. 0 by 0. Exactly. It's the only element. It's the only element that do not let you be reflex. Otherwise, minus 2, minus 2. Minus 1, minus 1. 0, no. 1 and 1. 2, yes. Everything we have it. But we cannot. So say 0 belongs to Z, but 0, 0 does not belong to this relation. Understood, dears? So you should be careful. Think about element, think about set, think about the given. What's divided by what? Second definition. Now we are going back to the examples. We have a definition, we apply to the examples. Definition, apply. So the second, it is a symmetry and anti-symmetry. Ta'an, what's a symmetry? Listen carefully. If we have A and B, you can see here, a remark, we have a remark. You can read this remark, it's very short, briefly. For each A and B, for all of them, okay. Let's say where no. If I have A and B, then we should have B and A. For example, if I have 1 and 2, I should have a 2 and 1. A and B, B and A. Understanding? Good. Then what's the anti-symmetry? Anti-symmetry, if we have A and B, we don't have a B and A. It's anti-symmetry. Or as he told you, and they are equal. Example number 7. Let me go back to the example number 7. Now I'm going to apply second definition. Where's example number 7? Here it is. Yalla, easy one, finite set. Tell me. Is the symmetry or not? One by one. Yalla, think about R1. Is the symmetry or not? I have 1 and 2. So I'm going to check 2 and 1. I have 3 and 4. Do I have 4 and 3? So no. You got it? Yes. 3 and 4, 4 and 3. Understood? 4 and 1, 1 and 4. Do I have it? No. So one example is enough to answer. R2. Yes. R3. I don't know. No. Why no? 1 and 2, 2 and 1. 1 and 4, 4 and 1. Nothing else, right? So yes. And think about it. Yes, God. Again? No. Again, just only reflexive within. يعني only. how go element أنا. كوا. نيمان لم set. أجد همو set أك بس reflexive يدي أبو yes. And 1 1 2 2 3 3 no more else. أجد أبو yes. But generally, if you say if reflexive symmetry, no. Because look at this example. 1 and 2. That example. Look. This is reflexive. But it's not symmetry. Tamam? That's why. Question. Okay. Now, example getir. This is example number 10. طبعا همون relation كان ليرة باسكرا. We have it, we don't have it. Go to example number 5. Show me which one are symmetry. Symmetry. طبعا the others are anti-symmetry, of course. يلا. Example number 5. Which one is symmetry and which one is not? Let me clear everything here. يا جماعة. It's like a game. If you understand, you can answer. Yeah. R1 is symmetry? Of course no. 1 year. R2? 1 year. Okay, 1 is greater than, 2 greater than 1, but I don't have a 1 and 2. I have a 2 and 1, but I don't have a 1 and 2, so no. Third one?
Yes.
Fourth? 1 year. This is all symmetry, reflexive. And you can say at the same time as what? Is symmetry. Because all element is symmetry. Reflex. How about that one? How about that one? Yes, no, no, yes, yes. Which one? Is yes or no? Maybe. Sometimes yes, sometimes no. Yalla. Which one? Which one more times? Yalla. No. It's for all integers, yes. 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 How many yes? 1, 2, 3, 4, 5, 6, 7. How about no? And the others sleepy, right? So no voting. Good. So, well, I don't know which one. And because if there's a lot, yeah. Can you give me an example? Give me an example is not symmetry. When you say no, you should give me one example. Okay. For example, say I have a 1 and 2, I don't have a 2 and 1. Hello, yeah? Are you sure we don't have 1 and 2? So 1 and 2 is here. 1 and 2. Also, you can write 2 and 1. So yes, it's reflexive. You can check every element. From the negative part, all are reflexive. For 0, 0, also reflexive. 1 and minus 1, 1 and 2, minus 1, you can reflect it. So, this is the example, and you need to think about it, Kaka. Yeah. What else? Well, lovely. Good. So we have R3, 4, 6. Kindly check it. There and there, you have a point. Why the other is not? Read it. Okay, dears. Good. Homework. The same. We have a positive integer. We have what? We have a divides. So make a set. Read the element. Write the element. Read all of them. Think about it. Then answer. Symmetry or anti-symmetry. One example is enough to be symmetry or not. Third definition. Reflexive, symmetry, transitive. We have a third one, transitive. Okay, so the third one is what? The third one, if I have A and B. Listen, Kaka, Listen to the remark if you don't like it. If I have A and B and strong condition and B and C, then I should have what? A and C. So first and third should be exist. I have 1 and 2. 2 and 5, I should have 1 and 5. Understood, dears? Good. Now let us start with the finite example. Finite example, example number 7. Then we are going to the infinite example, example number 5. So example number 7. Yalla. For transitive, tell me. Yalla day. For transitive, if I have 1 and 2 and 2 and 1, I should have 1 and 1. Do we have? Yes. If I have 3 and 4 and 4 and 3, 1, I should have what? 3 and 1. I'm going to check, do I have it? So it's not transitive. You got it? Dears? Shall I repeat it? It's clear, right? How about the second one? Right, because I have an and, I want to and. I have a 1 and 2, 2 and, so that's it. How about the third one?
1, 1, 1, 2, 2.
1, 1, 2, 2, 1. 1, 4, 3, 3. What's the problem with the 3 and 3? What's the problem? So, I think yes. Can you check it for me? I have 1 and 4, 4 and 1, 1 and 1. Yes, I have. 2, 1, 33. Yes, everything I think is already. How about R4? Do you think it's transitive?
Yeah.
Give me an element.
1, 2, 1.
We have what? 1, 3. I didn't understand. How? So give me the first. Give me, I have what? 2 and 1, you mean? We have a, you should give me both, then you told me the third is not exist. So give me the first and the second. Do you understand what I say? For example, like that. I say I have that one, but I don't have that one. So tell me like that. So we have a 3 and 1. So let me check one by one. Yalla. One by one.
We don't have.
I'm not talking about reflexive. I'm talking about transitive. So transitive definition is something else with the reflex. Okay, yalla. I have a 2 and 1. I'm checking 2, 1 and something. Do I have 1 and something? No. Forget. 3 and 1, 3 and 1, 1 and something, we don't have it. 3 and 2. Do I have 2 and something? Yes, now. I found it. I say I have 3 and 2 and 2 and 1. Do I have 3 and 1? You have it? Yes. So it means that I am wrong. It's also transitive. Now, we are going to check another element. Kaka. 4 and 2. 2 and 1. I have a 4 and 1. Do I have it? Yes. 4 and 3. 3 and 2. We have it. 4 and 3. 3 and 1. 4 and 1. We have it. Can you imagine what I'm doing? Do you understand, Kaka? Each element I'm going to check with the opposite one. So the end of each element should be with the start of the other element, the other pair. So yes, R3 also we have. How about that one? R6? Homework? Huh? R6? No, it's not transitive. How about you? Transitive? How about if I say yes? How's your answer? Can you analyze it? Analyze my answer? I say yes. Yes, okay. So I have 3 and 4, right? And I don't have anything. So false. I'll get what? False, then anything will give you true. Do you remember chapter 1? That's why I say because I don't have anything, by logic I say yes. You got it? How about the other? The condition should be satisfied. If the condition shouldn't satisfy, means that I have a mistake. I don't say if you don't have that one, it's true. Didn't I say that? No. I say if, here's the problem. We have a if, look, you have a condition. Say what? If you have a and B and B and C, then A and C. If you have that one, and then you don't have that one, means what? True and true. So, true. I am waiting for what? For false here. No, I will get what? False. Understood? But if I have false here with true, or true and false, by the result I'll get false. False with here, if true or false, I'll get what? True. Go check chapter 1. Yes, Kakam. If we don't have the second part. No, I didn't say that. Yes, the same example. I have a 3 and 4. Let that one be first P, okay? Let it be P. Okay? Or relation, okay. Now I have a R2. I say 4 and 3. Or P2. Tamam? Does not make sense. Anyone, because we have an and, you say A and B is equal to B and A. That's why. So the same. So if you don't have the exact condition, means that in the first part, left side, you have a false. Because I have a then, if the given is false, the other side, R, if it's a true or false, by the result, by default, I'll get a true. That's why I say yes, it's symmetry. Understood, dears? It's a little bit tricky, but that's why we took a logic in the first chapter. Where we are? So 4 and 5 and 6 are transitive. 4. So we did a mistake. Yes, we did a mistake here. Why? Wait, Kaka. We did a mistake here. So 4 and 5 and 6 are. So where's the other one? ما transitive, man. Wait. That one you see is not transitive. So why that one is not transitive? I have what? I have 1 and 2. 2 and 1. I need 2. 1 and I have it. But if I say let me change to what? 2 and 1 and 1 and 2, I should have what? Do we have 2 and 2? No. How about the third? Can you find the third one why it's not transitive? Let me check. 4 and 1. Hey, Jamaat, kindly think, video so. Sorry. Wait. Just give me 1 second.
Because we have 1.
2 and 1. 1 and 4. We found it, right? Tamam? Look at here. If I see I have 2 and 1, let me clear everything. Yalla kak. We have what? We have 2 and 1 and 1 and 4. So I should have 2 and 4. Do you have that one? No. So, and how about that one? We show it actually together. And that one's very important. That's all about transitive. Let me check. Transitive or not? Yes. Example 5. دقيقة. For transitive. Guess what? R1
Yes.
Can you give me one example that's not? Give me an example is not. Think about first one, Kaki Jandi.
We have -2, 0, 0, -2.
Wait. So you say -2 and 0. Eh? We don't have a 0 -2. We don't have it. We don't have it. This is the condition. So يلا. Do you think it's transitive? Why is not?
We have 1 and 3.
1 and 3. Okay. No. So you cannot find one counterexample, right? Can you think more? How about the second? Sorry?
3 and 1, 5.
1 and 5, okay. So I have 1 and 5. By your given, I have it. No, that was not true. Wait. And 1 and 3, I cannot put it here, 1 and 5 here. It should be 3 and something. If you say 3 and 5, we should have 1 and 5. Do you have 1 and 5 here? Yes, why not? Good. So is transitive. I don't think there's an example actually. I think a lot. How about R2? It looked like that one day. Take out R2. Symmetry? Yes. Give me one. Think about one example that's not true. That's better, yani, to think about which we have. You have the set like that. So think about it. Give you an example. We cannot do it. Yalla.
Not true. Same example, 1 and 3 and 3 and
1 and 3, 3 and 5. But your example is totally wrong. These two are not belong to R2. We have 3, 1 and 5, 3. Why? Because A should be greater. So careful, okay? Allah take bashka, you did a good mistake actually. You cannot bring something that's not in your set. So for example, think about it, we have a 3 and 2. Right? But this is not condition of this transitive. Here and there should be equal. So I don't have anything. So because you don't have anything means that it's true. So you don't have any example to give me the counter. Like we have a first part and there is no second part. Right? Like example number 6, R6. How about here? Here, for example, I have 1 and 1. And I have 1 and -1. And also I have -1 and 1. So we have what? We have 1 and -1 and we have it. So again, we have it. There's no example to give me the counter. Can you imagine for R3? Jamaat? R4? It's all reflexive, all symmetry. So you can say all what? It's all what? Also transitive. R5.
No.
Nothing? No idea? You cannot put the two numbers. Run. What? No what? No answer. No transitive. No transitive. What? Give me an example. Let me write. 3, 2, yeah. 2, 1. Bravo. And you are right. 100%. So we don't have it. So this is the counter example for R4, 5. That's 4. We have two numbers and yes. Condition satisfied, yes. Did I get the result? No. So that's it. R6, of course. R6, of course, yes or no. Give you an example. Let me write 4 and -1 and -1 and 2, 3. You are right. So 4 and 3, we don't have it here. Whatever you like. You can bring another example. -2 and 1, right? 2 and -1. 2 and 0. 0 and 2. And you can find many things, many examples. So because we don't have that one, is not. That's all about transitive. Kindly check more. You need time more to understand. Okay. I have one thing, and they are easy. It's not about thinking now. It's about just doing. So I'm going to finish that section, then I'll give you time. Yalla, now, refresh and not thinking, nothing, just do it. How? Listen to me, Kaka. Combining relations. I have two relations, R1, R2. So how you combine? Maybe union. You know how to make a two sets union. Intersection between two sets. Look at it. This is that one. So the intersection will be 1 and 1. How about difference? Means that in R1 you have it, you don't have it in R2. Kindly tell me which one we have. 2, 2, 3, 3, right? How about R2 minus R1? Means that in R2, but it's not in R1. So you can check that one. It's easy. Now, we have a composition of two functions, two relations, sorry. When I say R2, it's not R cross R. Careful here. When I say R2, because we are talking about relation, means that R circle R. Understood? It's not composition in the relation. It's not means that cross. It means circle. It means that combination, composition. So how we composite two relations? Look at here. We have a any set. We have a relation R and S. When I say S circle R, I mean by any element that related to here, it should be related in the set. Careful. Maybe the element does not exist in the circle. What do you mean by that one? Look at here. Look at this example. In R, I have what? In R, I have 1 and 1. Am I right? 1 and 1. In S, I have what? 1 and what? 1 and 0. Am I right? So I'm going to write 1 and 0 here. You got it, first element, Kaka? Hello? It's easy. Now, I'm going to the second element. Look, using different colors. So, 1 and 4. I have 1 and 4. So, I'm going to check 4 and 1. 4 and 1. I'm not going to repeat 4. I say 4 and 1. So, I should write what? 1 and 1. Understood? the composition relation does not depend, or the composite into relation does not depend on the R or set. Yes, depending on the composite of both of them. Now I have 2 and 3, green, 2 and 3. So I'm going to check 3 and 2, sorry, and 3 and 2. Am I right? Hello? Good. So I should have 2 and 1, 2 and 2. I think it's easy. That's a composition between two sets. And there's a diagram, there's a relation, there's all that you need to find. And we say that compositing itself does not mean the cross, means a circle. How do you know? So I have this relation, look Kakajan. I have this relation. Find Rn. I think this is the last example, if I am not wrong. Yes, last example. So yalla. Find R2 first, R3, R4, R5. Okay, how we find them? I have 1 and 1. And what else? 1 and 1 is with itself, right? So by the condition, I will get 1 and 1. Now, I have 2 and 1, but at the same time, I have 1 and 1. So I should have written what? 2 and 1 also. How about the 3? I have a 3 and 2. What else? 2 and 1. Am I right? So I'm going to write 3 and 1. You got it, dears? Shall I repeat it, Kaka? Silent. Shall I repeat that third one? Hello? Do you get it? Good. Now I have 4 and 3. Look, 4 and 3. And at the same set, I have what? 3 and 2. So I'm going to write what? 4 and 2. Understood? This is R2. How about R3? The same, depending on R2 and R. R2 and R. So now I have this set. Let's make the red. Now for R3, I have this set with that one. Like a previous one, do it. Or maybe I say R4. R4 and equal to the same R3. When you check it, you get the same. So it means that all Rn equal to there. Understood? By the default, we have a theorem. If you want to check transitive, if Rn is the subset for the first relation, you can say this relation is transitive. During the exam, this is a theory, during the exam, I'm going to give you, or maybe during the assignment you have it, I'm going to give you the R and I say show me it's a transitive or not. You can check it. That's all about today. Do you have any question?